are now doing things like Robin Huneke is a well-known producer and designer in the game industry, currently working at that game studio. Maggie Saif El-Nasser is now at Northwestern University, and I think we all know and love Maggie from the many conferences we see her at. Rob Zubek is a senior engineer at Zynga. So this sort of early group disseminated people out to do cool things in the world in the area of AI and entertainment. Today, Ian's going to be talking about the work he's been doing for the last few years on developing kind of lightweight, rapid methods for prototyping character behavior.
Thanks, Tom. It's been really, really wonderful being out here and talking to all of you. So I just want to thank you again for that. My default is going to be for this to be a relatively informal talk. And the good news is the paper for this got into AID. The bad news is that the reviewer comments were sort of all over the map, which made it clear to me that I was not doing a good job of communicating what the motivation was. So I'm actually going to be, I'm basically going to be talking about two things by default. What the motivation is, which I don't think will be a hard sell for this group, but sort of critique of the rhetoric of it would certainly be appreciated. And then also sort of what the user experience would look like. So I'm not going to be talking about, oh boy, this is how my physics solver works. Happy to talk about that, but by default I'm not going to talk about that. Okay, and I should also mention by user experience, what I mean is the experience of the person doing the rapid prototyping. Okay, so background and motivation. Obligatory facade slide. I want to do AI-based art and entertainment applications. However, I don't want to spend 10 person years developing a system. Not that I don't also enjoy doing that. So, when you want to do something like that, you're like, I'll use an off-the-shelf tool. And that works great, provided that you want to do an AI-based interactive entertainment application that's, heavy on running and jumping and shooting. And the media assets that ship with the engine that you're using happen to sort of match up to the affordances of your genre. And if they don't, then in principle, that's easy. You just go to your wonderful state-of-the-art motion capture suite and, pull in the animations for all the new actions of the new characters that you want. Except if you're like me, you're at Northwestern and we don't have a motion capture suite, and so you say, that's okay, I'll hire some virtuosic animators who just happen to be undergrads, except here I'm imagining that John Lasseter is a computer science major, because that was like the only Google image I could get of animators at work. But again, if you're at someplace like Northwestern, we don't teach animation. We have one computer animation course that's taught once a year with an enrollment of 15. And, that's sort of enough time to learn, what NURBS are and where the menus are. But I'm pretty sure they don't get to things like how do you do a walk loop or how do you really do good character animation, because there's just too much of a skill base that you have to develop. So then lots of people will say, well, if we don't bother to teach it in universities, how hard can it be? I'll just learn to do it myself. That usually doesn't work out so well, so it's easy to get discouraged. But don't get discouraged. Nevertheless, we have ended up in this sorry state where the ratio of actual interactive narrative systems to interactive narrative papers is near zero. So that's a problem. And that's kind of the problem that I want to try and deal with. So why is that hard? Well, one reason which I've kind of flogged now is generating, you need a lot of media assets for sort of a traditional engine, and generating those is expensive in the best case, but also in many AI research environments, you just simply do not have the human resources to do it. Sorry, you just don't. So that's one problem. And then, another problem is that it tends to be pretty hard to integrate traditional AI architectures cleanly into a game engine. Lots of people hook SOAR up to game engines, but they're not doing it by running SOAR in the address space of the game engine. They're having it talk over a TCP connection or something like that. So RPC ends up being the integration technology of choice. I'm very familiar with that from my days as a roboticist. And so you're spending all your time serializing and deserializing over TCP connections, and that has a lot of virtues, but it does have limitations. It's high latency for one thing. So in practice, you usually end up with control rates of 10 hertz on a good day. But then also, it's making a very strong distinction between what is the engine's business and what is AI's business. And if you want AI to be able to reach in and tweak something that you didn't anticipate having to tweak in advance, if you need a new sensor, if you need a new action, or if you want to be able to modulate some existing behavior to make it more expressive under control of like the anxiety trait or something like that, then that's a much more expensive operation to do. So what I want to argue is that we want to have some way of reducing the cost of doing experimentation. I want something I can play with and screw around with and try out ideas, but really have them running at relatively low cost. Because, this is sort of the pencil paper prototyping idea. Most of your initial ideas are not going to be good, so you want to work through them as quickly as possible. With AI-based stuff, it's often harder to know in advance. It's harder to pencil paper prototype that sometimes. So, I'm trying to make a tool that'll help you do that. So the first thing I want to say, is I'm not trying to do feature film production values. I'm trying to do something much more modest. I'm thinking more along the lines of webcomics. What would be like an AI-based webcomic? Or what would be AI-based WarioWare mini-games? Or something like that. Something where you can have a rapid test evaluating something. And for that, I don't necessarily need the high production values. You can tell great stories with a much simpler animation strategy, animation style, provided that you do it in an artful way so that the story matches the animation style, et cetera, et cetera. That's not to say that having higher quality animation isn't wonderful in many ways, but I'm not going to be able to do that in the short term, so I'm trying to look for what I can do. So I'm thinking more in this direction, or actually really more in this direction. And so the tool I need is a low-cost, malleable modeling technology that will allow me to quickly make some kind of a prototype of something, and if I don't like it, I can squish it and turn it into something different. That's the goal. Good so far? Any questions?
Who killed Gumby?
I did. He stole my girlfriend. Okay, so then there's sort of this question of, what would the tool you might like look like? And I don't claim to actually know this. So what I'm going to tell you is what my desiderata for it were. So my desiderata were cartoon believability, not going for serious realism, easy to interface to AI systems, easy to add new behaviors. And in particular, easy support for character behaviors that involve actual physical contact between the characters and other objects, including other characters. So, hugging, where you don't have to have some poor animator animate in advance that character hugging with that character from these initial positions for this period of time, et cetera, and have all of that be continuously tunable at 60 hertz by the AI engine if it wants to. Okay? Those are the technical desiderata, but then there's a bunch of social desiderata. I need something that doesn't require I have a school full of my experts, because I don't. And I need to be able to train people to use it without their already having an encyclopedic knowledge of both the graphics literature and the AI literature. It needs to be whatever the best approximation to novice-friendly I can manage is. And so my proxy for that is when sophomores take my virtual character, when computer science sophomores take my virtual characters class, will they die? So far the answer is no. Long term, I'd actually like to be able to have film majors take the virtual characters class and probably work with computer science majors, but have them do something cool that way. So I'd argue that that sort of pushes you toward a particular set of design decisions. So one of them is that in Twig, which is the system I'm going to talk about, everything has inverse kinematics. There just simply are no fixed animations that you ever play. Physics is running everything. So everything has inverse kinematics, and the inverse kinematics ends up being done through the physics system. So everything is always a physics object all of the time. That has certain advantages having to do with not having to deal with blending clips and so on. It also has the advantage, like, again, if you're trying to teach it to sophomores, that whoever is writing behaviors for the system never has to think in terms of a joint angle. They never even have to think of revolute coordinate systems. They can think in terms of Cartesian coordinate systems in whatever task-relevant coordinate system is good for them. So that sort of pushes you toward everything's going to be a robot. All of my characters are powered ragdolls. End of story. And since I come from a robotics background, I'm going to control them like robots. The ragdoll is just a physical plant for me that has control inputs and sensory outputs, and I'm going to build feedback controllers for it. Not particularly fancy feedback controllers from the standpoint of control theory. I'm going to do what I come from the tradition of behavior-based control, which is basically lots of really simple control loops competing with one another. But we actually program the thing in the same programming language that we program the robots in, called Biography. Everything should be scriptable. I want to minimize the number of times that someone trying to use the system walks up to me and says, I want to be able to change this, and my answer is, oh, wait a minute, let me modify the C# code. So I want you to be able to do the best approximation I can to everything from inside of an interactive scripting language. And then there needs to be good debugging support. Everything has to be in-game debuggable as best as possible. There need to be good tools for getting debug information back, and when you change something, you should be able to hot swap, for example, behavior out from inside of the mind of a running character without anything else being affected by it. Okay? So, those are my desiderata. The system that they are desiderata for is Twig, which many of you have heard about before. Before I go any farther, any questions? Yeah.
So you talked about like moving hands to places, and I guess you could probably move elbows too, but that seems like something you wanted to make characters able to hug each other.
Yeah.
And that seems like inherently difficult to do because like when you're thinking just about yourself, the positioning of like your joints and stuff is fine. But when you have something to like wrap your arms around, suddenly there's all these other constraints that you have to.
Right, and that's why physics is your friend. So in the current version, so let me show you hugging.
Okay.
Or a particular version of hugging. Oh, okay, so actually before I do that, let me just, so here's the basic idea behind how the, low-level, hello, there we go, there, behind how the low-level control works. You have a powered ragdoll, patterned after the Hitman engine, so the physical modeling is a bunch of point masses connected by massless rods. That's how dynamics works, and then you approximate that with whatever collision volumes you want to use on using cylinders for the moment. And then you can reach in and you can apply a force wrapped in a control loop to any one of these point masses. And you can in fact apply as many control loops as you want. And so posture control is you've got one control loop called stand up, which is just reaching in and attaching an invisible AI-based jetpack to the base of the spine and lifting the pelvis to whatever the right height is. Sit up is the same thing with the shoulders, and it's also servoing in the ground plane to center over the pelvis. There's also something that's centering the pelvis over the feet. Modulo issues of, you want to be leaning forward if you're running, you want to balance out the center of mass, et cetera, et cetera. You want to rotate the body, apply opposing forces to opposite hips or opposite shoulders, et cetera, et cetera. So it's kind of a weird thing. You're relying on physics, and yet you're completely violating physics, right? You're violating conservation of energy and conservation of momentum because you have these invisible jetpacks, et cetera, et cetera. But it's really easy to control, and it's completely numerically stable. So it's a nice sweet spot. It's not the ultimate, but it's a nice sweet spot for sort of a pragmatic tool. So that's what it looks like underneath. And then here's an example of it running. Hello? So this is a demo I've seen before. This is a little simulation of the attachment literature from child development. So you've got different behaviors that are competing with one another in parallel and changing how badly they want to have control of the body. And then for most things, whichever behavior wants to run most gets control of that part of the body. For posture, you're actually doing a weighted average based on how badly they want to run. And so here we have, that was a hug. I'm sorry, was that visible?
Yeah.
Okay. So here's how hugging works in that case for a child hugging a leg, which is admittedly the version I have implemented right now. Hold out your arms. Run, crash into the leg. When you feel contact on the torso, move the hands together. That's hugging. It's not perfect, but boy, is it easy to implement. And it produces, at least on a good day, it produces some reasonably expressive motion because you can sort of, you can use the physics engine to generate a, you get things like follow through, for example, automatically, just because physics is going to cause, and secondary motion also. Those things you get automatically simply because of the dynamics of the plant that you're controlling. Okay. So, was that sort of a useful answer? Okay. Let's go back here. All right. So I want to put in a minor rant here, because when I talk about this kind of thing, a common response is, that's great, but it's not AI. I want to say, motion is not automatically a SIG graph problem. And in fact, I think the AI community is really shooting itself in the foot if they abandon motion control to the graphics community, because as far as I'm concerned, well, for one thing, as a roboticist, well, like, of course it's an AI problem. Of course it's a reasonable thing for an AI person to work on. But also, my general view is, if it's behavior, then it's a valid AI problem. That's not to say the SIGGRAPH community isn't welcome to work on it also, but the triple AI community shouldn't say, oh, we can do that. That's for the SIGGRAPH people. I think we need to be thinking about this as an AI problem. All right.
Could I ask?
Yeah.
So I think if you were to say that to anyone who is a professional animator, they would probably be scratching their head and being like, artificial intelligence? Huh? No,
right.
Like, animation is art.
Right, well, and that's the thing. That's why I said behavior and not animation. Because as soon as you say animation, you are in some ways biasing people toward thinking, I'm trying to play back this one really great motion. As opposed to, I'm trying to improvise at 60 hertz a motion, complex combination of motions based on all kinds of factors that are varying in real time.
See, I would think like a high-end animator would not think that just replaying motion capture data is animation either.
Oh, absolutely. But what a high-end animator is doing is they're crafting a motion offline. So all I'm trying to say is online motion generation. Not pre-crafted and then played back, but online motion generation. I don't think the AI community should abandon that. I think we need to embrace that as being a valid AI problem. That's not to say that John Lasseter should go out of business and be replaced by an AI engine, because he shouldn't. It's a different problem.
Well,
related.
And it's interesting that in like the one sort of commercial community that does try to do improvisational motion, which is games, the character, the NPC AI folk consider animation an AI problem. Like within the industry, if you go to like the AI Summit at GDC or something, there'll be like whole sessions on animation at the AI Summit. And about the sort of very complex interplay between, and this is for game engines where it's still the playing back lots of snippets with like procedural layering and morphing. But even the playback lots of snippets with procedural layering and morphing as an AI problem, it turns into, I've got this big bank of snippets. I'm trying to do things in the world. How do I pick what to play when and layer it? And and I've seen a number of talks over the years about the really complex interplay between the AI designer and the animator who's creating those snippets. And they actually have to like talk really closely together, and the animator has to understand what the AI system is doing. And in fact, I've seen several commercial talks, which you might have seen as well, where people have extended their AI scripting language to include animators as one of the users. And so the animators are actually sort of doing their animations in the context of AI scripting. And so, I think for online animation, I think it's, there's only one community who's really caring about that right now commercially, and they have the religion too.
Right. Yeah. Whereas interestingly enough, the AAAI community mostly doesn't. And that's
yeah,
all
the
I need to
academics
say
are
is
behind
the
the
AAAI
times.
community,
Yeah.
when they see this, they really say, this is cool, but it's not AI. And all I want to say is, I actually think it's a valid thing for AI.
But even in Lord of the Rings, didn't on the crowds sequences, they were offline rendered, but they were little FSMs for like orcs and things that were, because just the hand animating all those characters was unreasonable to do, and you get a nice like fluid motion even with simple behaviors. So that's an AI problem too. Even
that's true. Crowd, the offline people have been using simple NPC techniques for crowds for a few years now. Yeah.
But it's interesting because like Craig Reynolds, I think, sees himself as kind of a SIGGRAPH guy, not really an AI guy, and yet to me he feels like he's kind of doing these kind of AI routines for crowds inside this work.
Right, and that's interesting because his boys work at the AI lab.
Right.
But in any case, it's fine with me if Craig thinks of himself as a SIGGRAPH person.
Actually, it'd be interesting to ask him. Like, now that I'm thinking about it, I'm like, I don't know how he self-identifies.
Yeah.
Well, he was.
And he goes to aid.
Yeah, and he does go to aid every year. Yeah, he goes to aid every year.
And he said he would have gone to AAAI if it didn't, if it wasn't the exact same days as SIGGRAPH. So given that choice, he goes to SIGGRAPH.
So really all I'm trying to say is that just because I'm not doing POMDP planning, or choose your favorite tool that's popular in AAAI this year, that doesn't mean this is an AI.
Description logic.
Right. Okay, end of rant. You can sense a lot of stuff. You have sort of low-level information. Tactile sensing, pain sensing, you can do visual sensing, ask, what's in view of this character, what's this character looking at. You get messages when a character says something, things like that. The weak point is bringing new props into the system. From a certain standpoint, bringing a new prop in is easy. You just compile your favorite mesh file using the XNA content pipeline and load it in. And as long as you're happy with the physics system wrapping a bounding box around it and using that as the collision volume, then you're fine. But if you want some fancier set of collision volumes, or you want an articulated object that has some physics to it and so on, I don't have a general theory of that right now. At the moment, you would be writing C# code. I want to set up something so you can at least annotate, add new, add a collision layer to your FBX file that specifies a set of collision volumes, and then the importer will, turn that into collision volumes. But at the moment, this is really the weak point of the system. Okay. That's kind of the low-level stuff, and really what I want to spend the rest of my time talking about is, what's it like to actually write a behavior for this thing? Before I do that, any questions? I don't understand why this thing keeps not working, which is very I will do it. All right, so behavior authoring. The last 2 summers, I've built some scripting languages into the system, so just easier to modify behaviors. And originally, I just wrote a Steam dialect, and that was the scripting language. I've since decided that there really needs to be some kind of classical symbolic AI engine so that you can dork around with pattern matching and stuff like that. And so I ended up implementing a horn clause engine, which initially you used with Lisp syntax, but then this summer I just decided it's worth it to write a Prolog reader for it, so you can read honest-to-God Edinburgh Prolog code into it and download somebody's random definite clause grammar or something like that. But basically, you've got some general purpose scripting languages. They're not intended to be super fast, which I'll go into in a minute. And you can pretty much attach a script to anything. You can script the individual objects in the world. They each have their own little namespace. There's a global namespace, their own little knowledge bases, blah, blah, blah. For the high performance stuff, there's a set of domain-specific languages built in. GRL, the robot language, which I'll talk about in more detail. I ripped off Steve Raven's finite state machine language. I ripped off Chris Hecker's behavior tree implementation. I ripped off definite clause grammars, which are sort of built into Prolog anyway. If I can find the right student to work with to finish off this project, I want to have a little embedded language for scripting the actual render passes. So if you want to switch between sort of the default Garot shading that you get with XNA versus tune shading versus shadowing maps, which all like have different kinds of passes and things like that, you would be able to do that interactively. Most of the infrastructure is there, but the rest is easy. And those things are then embedded in the host languages. Now, I don't know how common the idea of embedded languages is. So can I just ask how many people have heard of embedded languages before? Okay, so the basic idea is, let's say you want to make a little domain-specific language. You could go and write your own parser for it in YAC, and you'll write your own lexical analyzer, and eventually you'll decide it needs a module system, and so build your own module system for it. That's a lot of work. It also means you'll probably not put a lot of work into, say, building a debugger for it, because you're busy doing all this stuff. So the alternative is to essentially implement the languages as some kind of metaprogramming, macros, for example, in some more general purpose host language, and then you get the abstraction facilities, the module facilities, the debugging facilities for free from that. So that's what I did. Most of the stuff's implemented in Lisp, or you get at it through Lisp. The underlying implementation may be in C#, but you access it through Lisp, and you can use Lisp to write higher order procedures for working with it and so on. And then there's some stuff that's hosted inside of the DSL that you use for writing robot behaviors is called GRL, Generic Robot Language. It's a data flow language, so ultimately you're describing things in terms of graphs of signals that are feeding into one another and updating on every clock tick. It lets you do polymorphic programming, which tends to make it more concise and easy to write, but underneath it's strongly typed, runs at 60 hertz, and it's set up so that all the update happens an individual node in the graph, updates in constant time, so overall update is O(n). Nothing does any dynamic allocation, so it's O(1) space. So it's the kind of thing you want to have running in a game engine if you have to do something at 60 hertz. And then this then actually ends up being the language in the other DSLs that you use to describe things that you want to sample all the time. So if you want to have a state machine that's checking something at 60 hertz, rather than having special facilities for that in the state machine language, the state machine language has constructs that simply take GRL signals as inputs and checks them. So we're going to implement cheesy disco dancing. So let's see if I can do this. We're going to do okay, so 4 behaviors. Raising and lowering the left arm, raising and lowering the right arm, hip bumps, and then facing diagonally in opposite directions. Okay? And then there's a beat sequencer that's generating it that's not interesting. I'm happy to talk about it, but it's a sequencer. Who cares? So I'm not going to show you the code for that. Unless you really, really want to see it. Each of these things are behaviors. In behavior-based systems, basically behavior means some combination of what do I want the body to do and how badly do I want the body to do it. So I'm getting two signals as outputs from each behavior. And then there's competition between the different behaviors that are trying to drive a given body part. In most, depending on the application, the combinator you usually use is the highest activation behavior wins, but for some things like posture, you do a weighted average. So, how do we raise the arm? You have a reach left behavior who's always active, or always wants to be active, and it's trying to raise the left arm to a height relative to the shoulder, which depends on where we are in the phrase. Okay? I'm deliberately waving my hands through this since I'm assuming you don't want me to be teaching you skiing if you don't already know skiing. But this is embedded. Okay, so how do we raise the arm? This is a procedure, signal procedure that gets called. And raise arm is just going to create a proportional feedback control loop that says, here's where I want the arm to be, here's where it actually is, take the difference, multiply it by gain, that's my output to whatever limb I'm controlling, and I want that output to be controlling the acceleration of the end effector. Okay? That gives you raise the arm at the beginning of every measure. Good? Look, hip bump, kind of the same thing. We're driving a force this time on the pelvis. The force is going in one direction or the other depending on which measure we're on. And we're pulsing that force, we're pulsing the activation of the behavior at the beginning of each beat. So we get bump, 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 and then we get bump, bump, bump in the other direction. And then to do the bump, 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 to face alternately, we have another feedback loop that's controlling the orientation of the body. We give it an input vector that's alternating back and forth depending on which measure we're on. And, okay, the feedback loop is pretty straightforward. You do a little bit of vector math to get a scalar value that tells you what your error is, multiply that by a gain, drive that into the body. Good? Whoop. Okay, so let's do a demo. Okay? You know, it's not high art, but I'll notice you laughed. And it was pretty simple. You know, it's something that, for example, I can teach in an undergraduate class in 10 minutes and then have them do modifications of it. Good? Any questions?
Well, why do you use acceleration in one area but then force in another? I mean, that's
oh, sorry, it's really, it's not really force.
Okay.
I mean, there is an interface that lets you do real force, but most of the time, if you are really controlling force as a controller, then you're wanting to multiply your force by the weight anyway, so why not just say, look, I'm trying to control acceleration. Good point. Okay. All right, so let's say we want to do some sensing now. And we want to do a sort of stealth action mechanic where we want to be modeling the arousal level of a guard character and they get woken up when they hear sound. Well, how do we compute the level of noise they hear, take the velocity of the thief, divide it by the distance of the thief. We're going to take that as how noisy they are at the moment, or the square of the distance of the thief. And then their general arousal is just the integral of that. The longer and louder the person is, the more the guard wakes up. But it's a leaky integrator, so if they stop and are quiet for a while, then then the character will go back to sleep. That's the code for sensing that. And you can type this interactively, tweak all the constants, and it's just running at 60 hertz, and it just works. Now we're going to have the guard sleeping, standing up. And so we want to have them sort of do this. So we're going to put a force at the top of the spine, pointing forward and down. We're going to modulate the size of the force by what the arousal level is. The higher the arousal, the less it will be, and we'll modulate it with a sine wave so that they alternate. And then, that ultimately turns into this graph of little signals that the system does a topological sort on once, and then blasts through on every clock tick to update. Good? Okay, on that one. Okay, again, not great art, but it was easy to make. Okay, and so then finally, let's talk a little bit. The latest thing I've done is sort of put some simple symbolic programming stuff in so you can script that kind of thing easily. Eventually, I just gave up and said, okay, it's going to be Prolog. So Prolog is kind of the declarative language. You've got pattern-directed invocation, non-determinism. You have sort of limited constraint propagation by way of unification. It makes it easy to concisely express a lot of things. Not everything, but a lot of things. And when it works, the code is really simple and easy to explain. Now, there is the problem that when the code doesn't work, like all constraint-based systems, understanding why it didn't work is really painful. But here's the core of a Strix planner in Prolog. This is Johan Schoen's implementation. We're not going to walk through how this works right now, but just, even though this is more complicated than you'd like, this is way simpler than graph planning. It's much easier to talk about. Here's, a little English subset, grammar subset in Prolog. This is actual executable Prolog code. Sentence is a noun phrase followed by a verb phrase whose number attribute agreed. A noun phrase is a noun. A verb phrase is either a transitive verb followed by a noun phrase or an intransitive verb. Okay? All right, so and then if we want to add Montague semantics to it so that we get a logical form out of the parse along the way, we can do that where we say a sentence, by the way, whose logical form is this predicate, is a noun phrase whose logical form is some subject followed by a verb phrase whose logical form is lambda of the subject followed by the predicate. And sort of through the magic of unification, it all works. And I'll show you a demo of that in a minute. Not that I invented this technique, but it's a cool, clever technique. And it has the advantage that since it's all sort of working through this kind of limited constraint propagation, I can run this as a parser, or I can run it backward as a generator, or as I'm about to show you, both, where I give a partial sentence, which I parse, verify there's a parse, and then non-deterministically generate a random completion for it that's syntactic. Okay? So, demo. So I've always wanted to get a student interested in working on a game on gossip, and thus far haven't really succeeded. But in my group, we started trying to make gossip games. And so here's a kind of, this one really is just a tech demo, but so here's our tech demo of this game that we're sort of half working on trying to make, which is called Rupert Murdoch Presents Vicious Slander by Arno Jala, starring Glenn. And so in the game, you play the assistant to Glenn Beck, and your job is to figure out some way of connecting the victim through a chain of tenuous associations to the target concept by using a specified, connecting together a subset of a specified collection of target concepts. Okay? So here we are. Okay, so that's, sorry, I have no character behavior in this other than speak right now because I've been playing with the knowledge base, but that was Glenn telling you that we need to slander Arnav. Okay, so we need to connect Arnav to Satanism using this collection of concepts. And so I'll just give you the solution to the puzzle here. So what does Arnav study? Arnav studies, and let me just say, so there. If I type something that's non-syntactic, it shows this red. Otherwise, it shows you in gray a possible completion of it. And if I just keep hitting spacebar, it'll show me different possible completions. And these are only completions that are syntactically valid. It's not doing any semantic filtering on them. But in fact, the one we want is Arnav studies narrative. Okay. And so it parses that, understands that I'm proposing a move in the game, matches it against its knowledge base to make sure it's true, and matches it against what was the previous topic of the conversation, which was Arnav, to make sure that it's apropos of Arnav. And says, okay. So now, narrative tells stories, right? And you can either just give Glenn the moves, or you can lead Glenn to the moves. So you can also say, who else tells stories? And there you can see the logical form it's come up with is the dialogue act of rhetorical question of lambda s tell s story. Who else tells stories? Who else tells stories?
Satan?
Almost. Liars. Okay, and now what do we do?
Who else tells lies?
Close.
Who else is a liar?
I can see you haven't hung around enough with a certain kind of Christian. Who is the prince of lies? Satan. Okay. And Satanists worship Satan. We win. That's there. Now you have to promise me not to mention this to Michael Young, because at AID, I'm just going to, do a string substitution of Arnav for Michael Young, unless you would prefer to be the.
I don't care.
So the knowledge base can do a few other things. Arnav, it turns out, hates America because Arnav is a professor and professors are liberals and liberals hate America. Arnav's a terrorist because Arnav likes video games. Video games are violent, and who else is violent? Terrorists. Stuff like that. So the idea is to try and build that out and see whether or not we can do something fun with it. So that's the system. It's not good at accurate simulation. It's not trying to do photorealism. It doesn't even have a path planner. Right at the moment, it's just potential fields for navigation. But it's nice for roughing things out, roughing out procedural animations and then things to sequence and play with procedural animations. When Glenn Beck stands there motionless, that's not terribly expressive, but hopefully you got a sense that when the little kids were running around and looking around and so on, that can be relatively expressive, and so you get believability from that, at least on a good day. And it's not as good at authoring as I'd like it to be, but at least for me, it's easier than I'm going to download Unity and try and write my own procedural controllers for it, or mocap or what have you. And you can hook your AI system up to it via TCP, but also hopefully there's a fair amount of stuff you can do just directly natively in the engine. That's the idea. And then finally, I know that this is going to be a controversial statement here, but I think we need to build, as Michael says, playable experiences, and I think we can do that. But we need to make it easier to do that, at least if we want other researchers who aren't totally committed to making playable experiments to do that. And that's, I think, really an infrastructure problem. Partly about technical infrastructure, but it's also about human infrastructure. It's about, who knows how to do what things and, are in the right places together to be able to do them. Twig is trying to, push on the technical issue by making tools that are better matched to, the set of people who are in my orbit. In the long run, I think what you want to do is the kinds of things that you folks are trying to do with actually building programs to really train people with softer boundaries between this person is a computer scientist and this person is an artist and this person is a critic and so on and so forth. Okay. Thanks to all of my long-suffering early adopters, as well, and now also to Michael and Ben, who are my latest poor guinea pigs, and to many people, including Michael, for being encouraging on this project. Okay, thank you.
Yeah, for writing when you're writing drill code to do an animation like the disco, for example, or to do an animation behavior, how long does it take to kind of get the mojo to, because looking at it, not having ever done it before, it looks like I don't immediately know how to do it. If I was I wouldn't know, what I want to do is, you've obviously developed some idioms of what multiply is good for and what divide is good for and what average is good for and so on when you're shuttling these control signals around, these explorations around. When you're in your character AI class, for example, how long does it take to sort of communicate that mojo to someone new so that they can then sit down and really just start whipping up little animations?
Yeah, well, doing little animations, that part isn't hard. So I guess what I think is comparatively easy for them is if I show them a dance system, they can make a different dance system. And in fact, everything I show you here, except for Rupert Murdoch Presents Vicious Slander about Arnold Jalla, is in fact an example from the class that was written for the class, and that we go through in class, and then becomes an assignment for the students where it's done now do something that's like this but different. Some of the students one of the students did a reenactment of Thriller I mean, not really all of Thriller, but this like triangle of characters who are going around doing all of that. Others try to do jumping, which turns out not to have been something I anticipated in the engine, and that produced some interesting effects. So I think the answer is I don't know how long it takes to have someone really, get the zen of behavior design so that they could just go and decide to do something completely new. I think it can't be longer than it takes for a computer science major with no art training to learn real character animation, and it's got to be a lot less than that. Certainly, I have undergrads, who go and make stuff, and yeah.
How much do you anticipate just generating like a large library of these type of animations?
I think that's probably the kind of thing that's going to happen is you make a library of sort of standard things, and then people can tweak them, and then also reach in and add parameters to things. So, if you want a version of dancing where you can adjust the vigorousness parameters so that, you're simulating dance marathon, and, as time goes on, they get more sluggish. That kind of thing would be easy to do. Yeah.
And I guess, like, following up on that, do you have plans to curate that or, like, have a central website where, because it seems to me like there's multiple levels, and what's most interesting to me about this would be writing at a sort of high level where, like, somebody else wrote the, like, hug and kiss behaviors, and I want to write, like, some social thing where that I use them, but I don't want to write this myself.
Well, and in point of fact, that's what I want to do too. So I'm with you on that. And yeah, I mean, the idea is to build up a library of this stuff. Sadly, I think it's only now that I'm in a position to try to start doing that. But, like an early assignment next quarter is going to be, make a crying motion, make a shivering motion, make something that reads as crying, make something that reads as, being afraid, make a startle motion. It's kind of a lame startle motion that you saw in the stealth action thing. Do stuff like that, and then we can hopefully start both to develop a library of discrete actions and also maybe to understand what the underlying idioms are, and also, whether or not there ought to be some common infrastructure between those things.
Cool. That even seems to be like a really interesting AI experiment that you could do is take all the crying motions that your students produce, look at the actual physical simulation parameters and learn, the crying motion or whatever.
Yeah, that could be. That's probably a task for someone else, since I have zero experience with machine learning. Yeah.
How difficult would it be with this control system to do behavior that's a little bit more artistic based? Like the movement is pretty utilitarian right now. When they want to hug something, they go straight to it, stop on it, and the arms come around. But if, like, an animator or a performer were to do something like that, there might be extraneous movement in there that really is not utilitarian. It's just for the sake of the read and the poses that make a good hugging, readable motion.
Right, and the answer is, I hope it would be easy. And I'd really like to find an animator to work with to, try and do that kind of thing. So, for example, I know that I need more joints in the body. Because, I think it's going to be hard to do a depressed slouch.
Yeah.
I do have a spine joint, I don't have a neck, and I don't have shoulder. I have this shoulder joint, I don't have and so I don't know the anatomy, but I can't roll the shoulders in, I can't raise and lower the shoulders relative to whatever this is.